In this video, we're going to look at what are inverse functions. So very informally, inverse functions are going to be the opposite. That means that one function undoes the work of the other. So very informally, I tend to think of this as like parents and children, especially little children. So if you think of the parent, they want a perfectly clean house where they're not going to step on a Lego. And you think of the child, and they're going to dump out all the Legos. And so what does the parent do? The parent scoops them back up so they don't step on them. And what does the child do? The child dumps them all out. So they're opposite. One is dumping, the other one's picking up. Whatever one does, the other one undoes. And that's how inverses work in algebra. So we have a formal definition that if f and g are inverse functions, and then if you put g into f, or if you put f into g, either way, you will get back to x. So it's like when whatever g does, f will undo it. Whatever f does, g will undo it, and you will be back at start. So we're going to create a table of values for each function, and then we're just going to look at how they work. So this first function, f of x, our function rule is to take the x value and add 2. So -3 plus 2 is -1. -1 plus 2 is +2. 0 plus 2 is 2. And 2 plus 2 is 4. All right. G of x is the inverse function. And so g of x is doing the exact opposite. So it's minusing 2. So -1 minus 2 is -3. 1 minus 2 is -1, 2 minus 2 is 0, and 4 minus 2 is 2. Now, if I look at my two charts, I can see that the x and the f of x columns literally switch. So the f of x becomes the x for the g function, and the x and y values, if I think of these as x and y instead of as in function notation, literally switch. So if I think of this as y, over here, these are the same numbers that are in the x column, and the column that could be listed as y, those are the same numbers that are in x for the opposite one. So what happens? X and y switch between a function and its inverse. And it's that observation that helps us in actually finding the inverse for a function. So x and y switch. So what was in the x column is then in the y column. What was in the y column is now in the x column. Between the function and its inverse, they are switched. So because of that switch, we have a new test. And so we had before the vertical line test, but now it's going to become the horizontal line test because our axes are switching. Our x and y are literally switching positions. So the way the horizontal line test works. So first off, what does it do? It tests if the inverse is a function. And so the way that it works is if a horizontal line crosses the graph, more than once, then the inverse is not a function. Not word is key. So let's look at example. So if we have the function f of x is equal to x squared, the graph of that function is a parabola. It goes through the origin, so I'll try to draw a decent sketch of it here. And then if I would use a vertical line test, any vertical line would go through this one. So yes, it is a function, but truly I already knew that because it was in function notation. So I know from that notation alone that it's a function. But if I take a horizontal line and put it through, this horizontal line ends up intersecting twice. So the inverse is not a function. And the reason why is because the inverse, the opposite of squared, is square root. And we know that the square root would have to include a plus or minus. So this is what the inverse would look like. And we know that whenever an equation includes a plus or minus, it's not a function. So this inverse is not a function. Key thing, not a function. So depending how the question is asked, it might say, is there an inverse function? And the answer is no. There is an inverse, but it's not a function. So if they asked you, is there an inverse function? No, there's not. All right? So let's take a look at a second example. So for this one, we have f of x equals x plus 3. And so if I look at the graph of that, again, I'll try to draw a reasonable sketch, something like this. Well, I can see that a vertical line would only ever cross that once, so it would definitely be a function, and that's obvious because it's in function notation, so definitely a function. But then if I take a horizontal line, any horizontal line is also just going to intersect once here, or once there, or once there, but always only once. So yes, the inverse is a function. Or if the question was restated, is there an inverse function? Yes, there is. And so most of us would be able to look at this and think through in our heads, well, the opposite of plus 3 is just going to be minus 3, and you would be 100%. So the inverse function there would be that we'll use g of x as the inverse is equal to x minus 3, and we could tell that that doesn't violate any of our function rule laws, and so that definitely would be a function. So an inverse function exists if the horizontal line just passes